Hi Math, I'm Andy. Today we're going to look at the definition of a tangent line and use that calculus concept to find the slope of the tangent lines to the graph of f of x equals x squared plus 2 at 2 points, 0, 2 and negative 1, 3. Now these are 2 points on the curve, just to kind of give us an idea of what we're looking at here. The function is a parabola, x squared plus 2. I know it has a vertex here at 0, 2, and it's going to be an upward facing parabola. Now, the tangent lines are lines that kind of touch our curve at just one point. And so if we're looking at negative 1, 3, negative 1, 3, we'll just kind of eyeball is like that point on my curve. And so if I were to draw a tangent line, the tangent line's going to look like this. It's going to have some negative slope, and it's going to just touch that curve. Now the tangent line at the point 0, 2, well, as we said, 0, 2 would be the vertex. Now the tangent line would actually be different. It's not going to be that same negative looking line, but it's going to be horizontal, or somewhat horizontal according to my picture. Now we're going to find the slopes of those lines. Now, originally math kind of teaches us slope generally is the letter m, and slope is the change in y, delta y, over the change in x, delta x. Now we learned the slope formula, y2 minus y1 over x2 minus x1. Now calculus will give us another definition of the tangent line slope. It's defined as this. It is the limit as delta x approaches 0 of our slope delta y over delta x. Now this kind of expands out the limit as delta x approaches 0. Well, we get a 0 in our denominator. That's going to be a problem. And so we're going to use this process. We're going to use the concept that really the change in y, we're going to see it as f of x plus delta x minus f of x over delta x. And we're going to use this definition as the limit of delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now really this is just a very fancy way to rewrite the slope formula y2 minus y1, and you can check a calculus book for the definition as to why. But let's use this concept with our given function. So if I wanted to define f of x plus delta x, given the function f of x equals x squared plus 2, in a sense we're going to take that x plus delta x and we're going to substitute it into our function for the variable. So instead of x squared plus 2, it becomes x plus delta x squared plus 2. So all I did was replace the x with this new variable x plus delta x. So that's going to be our f of x plus delta x minus f of x, which we already defined as x squared plus 2, and then over this delta x. And so we're still taking the limit as delta x approaches 0 of this. So we just rewrote it with the given function. Now, because the limit as delta x approaches 0 still produces a 0 in my denominator, that's still a problem, I'm just going to have to use kind of some algebra to really just simplify what I have and hope that those delta x's are going to work themselves out. So we're going to expand this out. We're going to take x plus delta x squared and we're just going to square it. That's going to give me an x squared plus 2x delta x's plus a delta x squared plus 2. So I just kind of used FOIL, first, outer, inner, last, to multiply this x plus delta x times x plus delta x. You know, I just did my distributing property. And then I have this negative. Don't forget to distribute the negative. That's going to be minus an x squared and minus a 2. And this is still all over delta x. And I'm still taking that limit as delta x approaches 0. And again, I still have that 0 in my denominator. But I do notice a couple of things starting to happen. I notice that up here in one problem I have a positive x squared and I have a negative x squared. They're like terms. They're going to combine. They're going to cancel each other out. So this is, I don't have to worry about those guys. I have a positive 2 and I have a negative 2. They're going to cancel out. I don't have to worry about those guys. And so my numerator, what I have left up there is I have a 2x delta x and a delta x squared over delta x. And I'm still taking the limit as delta x approaches 0. But what I notice is I have now a common factor in my numerator. Delta x is a common factor. I can factor that delta x out. And so I can take delta x, put it in the front, and I'll have a 2x plus a delta x still there. And then my denominator is still delta x. And lo and behold, something now is going to change. I have a delta x factor in my numerator and a delta x in my denominator. I can cancel those out. And so what is going to happen now is I can now take the limit as delta x approaches 0, because all I have left is 2x plus delta x, and now that direct substitution method is going to work. I can plug in 0 and I just get 2x. So what did we just do? Well, going back to our original question, this is as far as I can zoom out, guys. So my answer is 2x. My question was to find the slope of the tangent lines. Well, just to kind of write this up, what I just did was I said, here's kind of what this answer means. So let me just kind of block this off. This means that the slope at any point, and I'll say any point x on the function x squared plus 2 is 2x. That's really what this answer means. So by using this definition of the tangent line, the slope of the tangent line, and breaking down my problem, it turns out that given the function x squared plus 2, the slope of any point on that line is going to be 2x. And so if I want to know what's the slope of the tangent line at 0, 2, well, that's going to be 2 times 0, which is 0. And that checks out because that tangent line to that vertex is a horizontal line. And if I want to know what's the slope of the tangent line at that point negative 1, 3, well, I'm going to plug in that negative 1 into my tangent line equation, so to speak, and I get negative 2. Now, negative 2 checks out too, because if I go back and I think about what this line looks like, it's a negative slope, and it looks like we could go down 2 over 1, down 2 over 1, down 2 over 1. So to answer our question, the slope of the tangent lines to the graph f of x equals x squared plus 2 at 0, 2, and at negative 1, 3, the answer is 0 and negative 2.